What's going on, guys? I'm back again with another MATLAB tutorial, and today we will be going over Simulink. Now, Simulink is basically, as the name insinuates, it's a simulator of a given function or for parameters that we can use to see how our system would be without having to build it. So if you know everything about your system, then you can model it as such, which makes it pretty cool. And so we can do that with Simulink. And so right now I'm just looking at an example. Obviously, uh, I was thinking of going and creating my own, but it's one of those things that it's not an easy problem to make up. So uh, I found the best way to do this was to look at a already made example and then kind of go over what each part kind of talks about. So here we have it's an open tank model. So if I hit run, I'll kind of show you. It's actually pretty cool, the fact that it's a simulation. So if I can see, let me try and pull up the actual. Let me see if I can grab the actual. So right now I'm not seeing the animation for it, but um, I will show you some of the components here. So right now this is just an input, and so let me see. I'll show you. If we go to the Explorer, this is where we type out our some of our commands. So if we want to do, so like this is one that I've already used and I worked with. I was thinking about showing that, but that one's also an example from from school and for a graded assignment, and I didn't want to do that. But basically, you see some of the similar things. Here we have these would be constants. So these are constants here, and scope. The scope is the big thing. That's what you want to. That's how you are able to view your data. So you can also do. I'm trying to let me see. Show you how to insert. We want to insert a function. Then we would go to yeah. So stuff like this. The amount of not parameter, the amount of commands in here is vast. So I'll go over some of the basic ones. This is the add. So say I want to have a constant, just one, and I can use these arrows and I can move it wherever. It just needs to be in an input. For this add function, I'll put it here, and so I'll do another constant, and I will put it here, and so this I'll make this. Again, you can change the properties of it. So this constant could be like something like 5, and also you can have like some overlapping stuff. Let me make this connection better. That's one thing that you will find is that it'll show you if it doesn't, and then we can just put this to a, let me see, a scope, and we want to have a scope to get our output, and then we can do that, and if we just run it, we should see. See, now it shows the simulation. I was trying to get that the whole time, but this is actually the scope for our constants that we use. So 5 plus 1 is obviously 6, so it's taking it time dependent. So you'll see this number won't change as we go. But now that I have my tank model up, I'll stop the simulation, and I'll actually show you what they have come up with, or what MathWorks or people at MATLAB. It's one of the open examples they've come up with, and this can help show you some of the problems with this is that you don't actually get to see, like you if you're new to MATLAB and you look at this stuff, you may not know exactly what it means, but let me try and show you some of the blocks that it is able to use. So let me just delete that. I can go and look at this. Alright, so we know this is a subsystem mask in valve. Let's look up subsystem, and So you see you have an input and an output, and that's basically what this is. They've defined it as their in valve. So you can also add in other positions. So let me show you how to do that. If I go, let me see, I'm pretty sure I can add a output and create two outputs. So I can also have multiple inputs. As you see, they have, I just did that, and it will, now I have two outputs. So that's what they did here. They took a subsystem, kept one input. You can also have multiple inputs. They just chose to break this up to help out the problem, just because it makes it easier on them. So as far as like the webbing of data goes and what they chose to design, you could probably do this 2 or 3 other ways, or actually probably as many ways as you can come up with, but that's just what they chose, or what they thought that was going to be the most efficient. So that is how you create a subsystem of block, and obviously you can take these and add them wherever you can do. Now you can do this, which means that this is, you would probably want to do, put in an add function if you wanted to add your, I think it goes to, oh shoot, let me undo that. If they wanted to like add something in here, you would just put in an adder, like we've done up here, into one of these, and it would then be additive. You can also do this for other things like a multiplier. You can do that. So this is just like a constant multiplier, so you can change that. So if you want 2 times from something, instead of having to type that out, you can just do a multiplier, and I'm sure there's a divider as well. So yeah, you can do all your basic arithmetic through it as well, which makes things easy when you have constants and things running through. So yeah, they just have multiple subsystems here, just kind of explaining what these all are. This is this is just another output that they have, just so that you could also look at this. Like you can go and check out your flush pulse, because we've had it here. We would just have to connect it up to the scope. Also, the thing with the scope is what you'll probably be using the most, so I'll probably want to go over that a good bit. If we click on our scope, let me see about editing it. We can see, let me try and get to, let me see if I remember correctly. Some of this stuff I haven't used in a while, so not to bear with me, but some of this stuff can get kind of complicated. So it's shoot, yeah, some of this stuff is not stuff that you would use every day. So see here we have a number of input ports, so we can say there's like 6 inputs. Now that's probably a little a little too many, but let me go and change that. Sometimes it's hard to see. Here we go. That's good. Alright, so I was in the right place the first time. So if I just type in scope, I can then, this would be a right click, signals and ports, and then I can select how many of ports I want. And just for a visual, I'll do 3, because that kind of looks somewhat, there we go. So I can see what, I can actually see what I can take that and add on and see what the flush pulse is. I can see what the out valve is, and I can also see what the, oh, don't want that. I can also see what the tank height is. So if I just click on the scope, I can run this, and it'll show me all 3 of those. Now, if you're doing this, you'll want to differentiate what is what. Some of these aren't displayed right now. It's probably because they don't. I believe it would probably be, we're seeing tank height. I know tank height is the yellow, and I would want to say that, I'm assuming flush pulse would be 0 here, but I'm also trying to figure out what is our unknown that we don't see. So, okay, here's a blue that came into play, so that means it was non-existent, or it was 0 up until this point. So we have that going, and so that makes sense that it would be, let me see, that'd probably be the flush pulse because of just how it's oscillating. But I'm going to close that down just because it's using up a lot of power for that. So I'm going to, once I delete this scope, it's running still. So can I just cancel this run? I guess not. I can hit pause potentially. I guess once it's running, it's running. But let me see if I could stop it. Yeah, I think you just gotta let it run. Let it run to completion and then get rid of it. Oh, yeah. So those are kind of the main ones. Subsystems will definitely help you out. The scope is how you view your data. There's adders, there's constants, there's different inputs that you can do and things like that. So once this one is done running, I will look at this scope and actually pull up the simulation because it's actually really cool what they did. And so I think it'd be helpful to just kind of see how it works, and hopefully this thing's done. No, you don't want it to be done. Alright, maybe you're done now. Oh, gotcha. Alright, well, I'm just going to click on the scope. Maybe this one's still running. But so we'll take that to the end and we'll see if that changes anything. But yeah, we can see that yellow line was denoted as our tank height, which is what we also found through our scope. Now we can get rid of it, and you can just delete these lines too. So it won't change our final answer. So let me see if I hit run if that simulation comes up, because it's a very cool simulation. I'm just gonna pause this then and exit out, and I'm trying to see. Sometimes I think if it's this one to get the simulation up, if I'm not mistaken. So we'll see what happens there. No, they just don't like it. Yeah. So I'll pause it. Let me see if okay, so never mind. I hit it. Sorry. So you can stop that. So this is actually really cool. It shows, this is just from, you can read from the title. It's just a tank filling and emptying example in animation. Now obviously they have functions for their flow in and their flow out, and so that's what this is. And so we see that our or they have functions for their tank height and tank they have functions for their tank height, and that depends on different parameters of these. The way that they decided to break it up was with in valve versus out valve, and so what they did is they broke it up into the positions and the rates. So also with the out valve, there's a flush signal, I guess. So I haven't actually seen the problem statement. It's more of just like a simulation to show you what to do. So it's pretty cool, and I'll just run you through what you see while it's running. So I will play this. Let me see if I can get these to coincide, because it's really cool to get it going. So I have, gotta restart it. So if I do that, then we do play. So we can see as this value, our tank height is going up, we also see in our simulation it's also going up. Now it's going to keep increasing linearly at this point. I believe that's a linear increase. Yeah. So it's going to keep doing that, and we see we've hit a certain value and it's flatlined. Now at this point you'll notice there's a valve there, and that is what is stopping it. So then we have that outflow, and then we start then we have the outflow, and then the valve comes down, and we again start to increase. And so it just shows you a couple cycles of this. So I can just pause this. I believe that got through the idea, but you can change. The really cool thing that I thought about this simulation was the fact that you can change these different parameters, and it'll actually change the actual blocks. So that's really cool. Now this is obviously something that if you're a beginner to MATLAB would be way beyond the scope. I've had some, I mean obviously I've had some experience with it. I wouldn't call myself an expert by any means, but this is definitely beyond the scope. They've clearly made a graphic user interface, and so that's a different type of language to use. So don't expect to be making this on your first day trying it. It's just a cool little physical model to show you what your scope is telling you, and so that's why I thought it was cool. But yeah, the certain parameters, and then that goes into this, and then output and all that. And see, we can kind of see what they do in here. So there's a little subset in it. So we have we have our tank height, which is an input, and we have taking, see, they've got their sum there. So I showed you that function a little bit. This is an absolute value, so that's abs. And then you see what this one is. I'm kind of unfamiliar with this actually. Memory. So okay, so it's just a cycle basically, and then we have another signal. So that's another port, and then this is to make it a double, so it's data converter. So that's pretty cool, and yeah, it's nice. It's and then there's gain. I've seen those, and so it's almost like our, if we pull up, let me see if I can add something. No, it won't let me, but kind of looks like our multiplier that we showed earlier. Let me see what's behind this guy. Okay, so there's this one would be so gain is just similar to a multiplier, obviously, but this is almost a divider because it's 1 over the area, and I believe take area is known, so have that. And so oh yeah, this is another guy. There's actually an integrator here, and this is really cool because you can put in so they have each limit, and that's their initial their IC, so they have that, and you can actually integrate in Simulink, so that's pretty cool. They have another summation, so we see some of the things that I've talked about, so that's pretty cool that they're actually taking into account some things. And here's some more data converters. Not really familiar with the multiplex scalar or vector signals, but this is for the animation, so I don't have too much experience with that, but yeah, I think that's a good bit on Simulink, and there's definitely a lot more that you can do with it. This is really just a broad stroke of it, just to kind of get you introduced to it. Some of the basic commands, or not commands, I don't even know what you call them, but blocks. I think that's what the correct name is for them, is is blocks in Simulink. So also in actuality, if this wasn't just a open example, you would also have some code in there to say what certain things are. I believe that's already that's going on behind the scenes while this is going on, but I'm just gonna close this. Yeah. Oh yes, I want to stop it, so I can do that. Yeah, I want to stop that. No, I don't want to save it. So yeah, it was just a really cool example that I wanted to show off for you guys and maybe explain through, because I know if I saw that the first time I was using it, I would be able to understand it. So hopefully that helped out, and best of luck with your Simulink moving forward, and have a good day.